It's the magic of math here, and today we want to find the solution of this system of equations where we have to identify what value of x and what value of y will make both of these equations true. Here's our question. We're asked to consider the system of equations y equals 3x plus 10 and 3y equals negative 4x subtract 9. We want to know what is the solution of the system of equations, and we're given 4 answer choices to pick from. Here's where you pause the video, do your best work, and then come back to see mine. Good luck. Welcome back. So we are going to find the solution of this system of equations. We are going to use substitution as our method today. You can pick a different one, but I'm using substitution since this equation is solved for y, and I know that y is equal to 3x plus 10. I can replace y in the second equation with this expression, 3x plus 10, and then I only have one variable, and I can solve. So let's do that over here. 3 times y, which I know y is 3x plus 10, equals the negative 4x subtract 9. So since I know there's a relationship in the system, y is equal to 3x plus 10, I evaluate for this y to be 3x plus 10. All right, now let's solve this equation. We are going to distribute the 3 to the 3x, which is 9x. 3 times 10 is 30. So this becomes 9x plus 30, and then we have our negative 4x subtract 9 to the right of the equal sign. Now I'm going to collect variable terms next because I have variables on both sides of the equal sign, and I'm going to collect them to the left side of the equal sign. So I'm going to do the inverse of negative 4x, and I'm going to add 4x to each side, giving me my zero pair. 9x plus 4x is 13x plus my 30, and I have my negative 9 left here on the right. Now I want to get all my constants to the right side of the equal sign. So I'm going to do the inverse of add 30, which is to subtract 30. What I do to one side of an equation, I must do to the other. So here's my zero pair, leaving me 13x on the left side. Negative 9 and negative 30 are negative 39. To solve for x, I'm going to do the inverse of multiply x by 13, which is to divide by 13. Again, what I do to the left, I must do to the right. 13 divided by 13 is 1x, and then negative 39 divided by 13 will give me x equals negative 3. So I know that x is equal to negative 3. I now need to know the value of y. So I'm going to pick the first equation to evaluate when x is negative 3, what will y be? You could use the second, but I'm going to use the first. So we have y equals 3x plus 10, but I know that x is negative 3. So let's rewrite that. 3 multiplied by negative 3, or x, add 10, and then we'll solve for y. 3 times negative 3 is negative 9. Negative 9 add 10 is positive 1. Now I have my x and y. We're going to write it as an ordered pair because this is the point where these two lines will intersect on a graph. It is also the solution of the system because it is the only point that is true for both equations. If I plug negative 3, 1 in, it makes both of these true. So my answer choice is B. Thanks for joining me today to determine the solution of a system by solving by substitution. And we found our XY ordered pair, our point of intersection when these two lines are graphed on a coordinate plane. Thanks for joining me today at the Magic of Math, where we continue to master math one video at a time.